Have you ever looked up at the night sky? You see stars, planets, and galaxies. You feel the ground beneath your feet. Everything seems solid, real, and three-dimensional. But what if all of it is an illusion? What if the universe we experience, with all its depth and complexity, is actually a projection? Imagine a vast cosmic movie, where you are not just a spectator but part of the film itself. This isn't science fiction. It's an idea that some of the world's leading physicists are seriously considering. It's called the holographic principle, and it suggests that our three-dimensional reality might be encoded on a distant, two-dimensional surface, much like a hologram on a flat piece of film. To understand how physicists arrived at this incredible idea, we must first travel to the edge of a black hole. A black hole is a point of no return. Once you cross its boundary, known as the event horizon, you can never leave. For decades, scientists believed that anything falling into a black hole was lost forever. Its information, the unique arrangement of its atoms, its history, its very essence, was thought to be completely erased from the universe. This created a huge problem, a paradox that pitted two pillars of modern physics against each other. The laws of quantum mechanics insist that information can never be destroyed. It can be rearranged, but it can't just vanish. The debate over the information paradox wasn't just an abstract academic puzzle. It became a personal and passionate battle between some of the greatest minds in physics. In one corner was the legendary Stephen Hawking. Using his profound understanding of gravity and space-time, Hawking made a startling calculation in the 1970s. He discovered that black holes are not completely black. They slowly leak a faint glow of radiation, now known as Hawking radiation. Over immense periods of time, this leakage causes the black hole to evaporate and eventually disappear completely. In the other corner were physicists like Gerard T. Hooft and Leonard Susskind. They were defenders of quantum mechanics. To them, it was a non-negotiable law of nature. He famously described the disagreement as a war, a scientific battle for the soul of physics. The breakthrough came from looking at the problem in a completely new way. Instead of asking what happens inside the black hole, physicists started to think about what an observer far away would see. From our perspective, as something falls towards a black hole, time itself seems to slow down for it. It would seem to stretch and flatten against the event horizon, frozen in time for all eternity, never quite crossing over. They suggested that all the information about an object falling in, its shape, its chemical makeup, its history, gets imprinted onto the two-dimensional surface of the event horizon. The information isn't lost inside, it's scrambled and stored on the boundary, like a complex blueprint painted onto the black hole's skin. The Hawking radiation that leaks out wouldn't be random after all. It would be subtly imprinted with the information stored on the horizon, carrying it back out into the universe piece by piece as the black hole evaporates. This elegant solution resolved the paradox by showing how information could be preserved without violating the laws of gravity. In 2004, Stephen Hawking finally conceded his bet, admitting that information was likely not lost in black holes. This was the seed from which the holographic principle would grow. The information required to describe a three-dimensional region of space can be completely stored on its two-dimensional boundary. The resolution of the information paradox did more than just settle a debate. It gave birth to a revolutionary new principle. This is the essence of the holographic principle, first formally proposed by Gerard T. Hooft and later developed by Leonard Susskind. The holographic principle suggests that our entire three-dimensional universe could be a projection of information stored on a distant two-dimensional surface at the cosmic horizon, the edge of the observable universe. This cosmic boundary would be like a definitive library of everything that has ever happened or will ever happen within our universe. Every event, every particle, every interaction would have its corresponding entry encoded on this distant screen. The laws of physics as we know them, playing out in 3D, would be a consequence of the simpler 2D rules written on that boundary. Our reality, with all its seeming depth and substance, could be thought of as a grand hologram. The story of the black hole information war didn't just save physics from a paradox. It handed us a completely new and deeply unsettling picture of what reality might be. To truly grasp the holographic principle, we need to understand what a real hologram is. It's more than just a fancy picture. Think about a regular photograph. A photo is flat. It captures a scene from a single viewpoint. If you move your head, the perspective doesn't change. A hologram, however, is completely different. It's a special kind of recording that stores not just the light, but also its direction and phase. When you look at a hologram, like the little dove on your credit card, your brain is tricked. As you tilt the card, your viewing angle changes, and the image appears to shift as if it were a real three-dimensional object. The creation of a hologram is a clever process involving lasers. A laser beam is split in two. One beam shines on the object, say an apple, and then bounces off it onto a special photographic plate. When these two beams meet, they create a complex interference pattern of microscopic swirls and lines. This pattern looks like meaningless noise to the naked eye, but it contains all the information about the apple's shape, size, and texture from every possible angle. It's a complete three-dimensional blueprint, squashed down into 2 dimensions. When you later shine a light through this patterned film, the original light field of the apple is perfectly reconstructed. A 3-dimensional image of the apple appears, floating in space, looking so real you might feel you can grab it. Now we take the final mind-bending leap. The holographic principle proposes that this isn't just a quirk of black holes or a neat piece of technology. It suggests this is how the entire universe works. It asks us to seriously consider the possibility that our entire cosmos, with all its unimaginable vastness and depth, is a holographic projection. This means everything we experience might be coded on a distant 2-dimensional surface. Think about the implications. Every star you see in the night sky, every galaxy spinning in the void, every person on Earth, all of it could be the manifestation of information written on a cosmic boundary. This boundary, called the cosmological horizon, is the farthest edge of our observable universe. It's a sphere that surrounds us, marking the limit from which light has had time to reach us since the Big Bang. The principle suggests that this boundary isn't just an edge, it's the hard drive of reality. Our 3-dimensional world would be the image playing from that drive, a grand illusion generated from a flat cosmic screen. The answer is that the projection would be perfect, indistinguishable from what we call real. The hologram would generate not just images, but the very fabric of space, time, and matter. It wouldn't be like watching a movie, it would be like living inside it, with no way to tell that the theater itself is just a flat screen. Our entire existence could be part of this cosmic light show. If our universe is a hologram, then, like any digital image, it must be made of pixels. The holographic principle suggests that space itself might be pixelated in the same way. There might be a fundamental smallest possible unit of space, a cosmic pixel, beyond which you just can't zoom in any further. This smallest possible size is thought to be the Planck length, which is honestly an incredibly tiny distance, about a trillionth of a trillionth of a trillionth of a meter. According to the holographic principle, our universe is composed of a finite number of these Planck-sized pixels. Each pixel on the cosmic boundary stores one fundamental bit of information, a yes or no, a 0 or 1. This idea of a grainy holographic universe is not just philosophy, it's actually a testable scientific hypothesis. One experiment, called the holometer, was designed to see if it could detect a tiny jitter in space-time itself. The idea is that if reality is a fuzzy projection, then the positions of objects might not be perfectly sharp. They might wiggle around a tiny bit, limited by the resolution of the universal hologram. After years of careful measurements, the holometer experiment did not find the specific holographic noise it was looking for. This result ruled out some of the simpler models of the holographic principle, but it didn't kill the idea entirely. Finding evidence of this cosmic graininess would be one of the most profound discoveries in the history of science. It would confirm that the solid world we experience is just a projection, and that the true reality is a flat information field at the edge of the cosmos. If the holographic principle is correct, it really forces us to ask a very deep and personal question. What does it mean for something to be real? Our everyday definition of reality is tied to our senses. A table is real because we can see it, touch it, and place a book on it. But the holographic principle suggests this sensory experience, this perceived solidity, might be a clever illusion. Now, this doesn't mean the table isn't there. Your experience of the table is perfectly valid. It has mass, it occupies space, and you certainly can't walk through it. The hologram is, in a sense, as real as it gets. This forces a major shift in our scientific and philosophical worldview. For centuries, science has been reductionist. We've tried to understand the world by breaking it down into smaller and smaller fundamental parts. Molecules, then atoms, then subatomic particles. But the holographic principle suggests we may have been looking in the wrong place. The fundamental reality might not be smaller bits of stuff within our space, but rather bits of information located on a boundary surface far away. This new perspective doesn't erase our world. It reframes it. It suggests that our universe is fundamentally made not of matter or energy, but of information itself. So what is our place in this grand cosmic hologram? We are not separate from the hologram. We are an integral part of it. We are the projection, and the projection is what is real to us. Think of a wave in the ocean. A wave is not a separate object. It is a pattern of energy moving through the water. The water itself is the ocean. In the same way, we are not separate from the universal hologram. We are patterns of information unfolding within it. Our consciousness, our ability to observe and question the universe, is one of the most complex patterns the hologram has produced. We are the universe's way of looking back at itself. The information on the boundary doesn't just project stars and galaxies. It projects beings capable of discovering that they are a projection. Our quest for understanding is the hologram itself becoming aware. We are intricate, self-aware patterns, projected from the edge of reality, woven from the same informational fabric as the entire cosmos. We have journeyed to the edge of a black hole and to the boundary of the observable universe. We have seen how the fight to save a fundamental law of physics led to an idea that reshapes our entire concept of reality. The holographic principle, born from the ashes of the black hole war, suggests that our three-dimensional world may be nothing more than a complex projection of information stored on a distant, two-dimensional surface. This is not just a wild fantasy. It is a serious scientific proposal supported by powerful mathematical evidence. But for all the questions it answers, it leaves us with even bigger ones. If our universe is a hologram, what is the projector? What physical mechanism is responsible for taking the flat, two-dimensional code on the cosmic boundary and generating the rich, three-dimensional world we experience? This is perhaps the greatest mystery of all. Understanding this would be a monumental leap, potentially leading us to the long-sought theory of everything that finally unifies the world of gravity with the world of quantum mechanics, a goal that has eluded physicists for a century. Furthermore, what lies beyond the boundary? If our reality is encoded on a surface at the edge of the cosmos, what is that surface floating in? Is there a higher dimensional space in which our holographic universe is embedded, like a bubble floating in a larger existence? It opens the door to the possibility that our entire cosmos is just one bubble among many, a single page in an infinite library of other realities, each with its own laws and its own holographic screen. And what does this mean for the future of scientific discovery? If the fundamental reality is two-dimensional and inaccessible, does that place a limit on what we can ever know? The search for the graininess of space-time is one attempt to see the pixels of the hologram. Finding it would be a triumph, but it would also confirm that our perception of the world is limited by its fundamental resolution, a cosmic veil we may never be able to peer beyond. The holographic principle does more than just challenge our scientific theories. It fundamentally alters our relationship with the universe. It suggests that the world is not what it seems. The solid ground we stand on, the air we breathe, the stars we gaze upon, all of it may be part of a grand illusion. This can be a deeply unsettling thought, but it can also be a source of profound wonder. It implies that reality is far more mysterious, intricate, and interconnected than we ever could have imagined. We are not just cogs in a mechanical machine, but characters in a story written in the language of information on a cosmic scale. This new perspective invites us to be humble. For all our scientific progress, we may still be just scratching the surface of the true nature of existence. The holographic principle is a powerful reminder that the most profound truths about the cosmos are often counterintuitive. and will require us to stretch our imagination to its breaking point. It also offers a new sense of connection. If everything is projected from a single unified information field on the cosmic boundary, then the concept of separation is an illusion. Every particle in the universe is fundamentally entangled with every other particle. The information that constitutes you is woven into the same fabric as the information that constitutes the most distant quasar. This paints a picture of a holistic universe, where every part is a reflection of the whole, a truth that many philosophical and spiritual traditions have spoken of for millennia. In the end, whether the holographic principle turns out to be the final truth or another stepping stone on the path to a deeper understanding, its value is undeniable. It has forced us to ask our boldest questions yet. It has pushed the boundaries of what we thought was possible, and has expanded our vision of the cosmos. It challenges us to see the universe not as a collection of objects, but as a dynamic, unfolding process of information. And it places us, as conscious observers, in a special role. We are the part of the hologram that has woken up and is now trying to read its own source code, a truly magnificent and mind-blowing quest. It suggests that we are living in a universe that is far stranger, more mysterious, and more interconnected than we ever imagined. We are not just collections of atoms in an empty void. We are intricate, self-aware patterns projected from the edge of reality, woven from the same informational fabric as the entire cosmos. Our reality is a story written in the language of information, and we are both the characters and the readers.